Hi everyone, my name is Marissa Katsuda, and this is my unit plan on congruence of triangles. Now, this unit will be found in a mathematics class, specifically geometry. And so, just jumping right in, on the left is the unit summary. And the first sentence says that triangles are the basis of everything, so this unit you will be learning different methods to prove that a set of triangles are congruent. And it kind of goes into what students should expect in the future of this unit. On the right are the California standards. There are 3 that we will be going through this lesson. And like I said, it is mathematics. The grade level is 9th or 10th grade, just depending on the student's proficiency with mathematics. The big ideas that are very important are students will leave this lesson knowing how to prove a set of triangles are congruent to one another. Next, a student will leave this lesson knowing the properties of congruent triangles. And lastly, and arguably the most important, I think, is the students will leave this lesson knowing how congruent triangles can be applied to our daily lives, like architecture. And you'll see later that this is a summative assessment that students will have to present how congruent triangles are applied in their daily lives. Now, the student learning objectives are students will be able to prove that 2 triangles are congruent by each of the tests, SSS, SAS, ASA, HL, and AAS. Students will be able to use past theorems to prove that triangles are congruent, for instance, vertical angles, isosceles triangle angles, and their sides, and etc. And students will be able to use congruent triangles to prove another set of triangles are congruent. And lastly, students will be able to apply this to future geometric problems and theorems. And now all of these can be observed by students' proofwriting. If the student can complete a proof without any guidance, then the objectives have been fulfilled. And so it's very important for me as their teacher to be very nitpicky on their proofwriting, just to make sure that they are critically thinking about how these 2 triangles are congruent and what theorems they can use to prove that these triangles are congruent. Now, there are a lot of theorems that they already know, so it's just a great way for them to really review back on what they've already seen. So this right here is my menu bar, and you can go ahead and click wherever you want, but we're going to jump right into assessments. So assessments, right here we have the formative assessment. So for this one, I have openers, which is like a small quiz, and it's going to start off the next day's class. So this quiz is based off of yesterday's or the day before's lecture notes. And so if the students understand the lecture and they were able to do the homework, then they should come into class ready for just a 2 or 3 problem opener. Now this one is really focused on SAS, HL, and SSS. And students will have to prove that these triangles are congruent those 3 ways. And it really gives me a good way to see if I have to review the next day on any of these 3, just so that students don't get further and further behind in this unit. The summative assessment is going to be a presentation on how are congruent triangles used in the real world. And the directions are for them to find an example of congruent triangles. And next is to propose their example to me by a certain date, depending on when this presentation is brought up to them. And it is a first come first serve basis, just because I only want to accept 5 examples or 5 of each example, just because I know a lot of students probably want to go the easy way and just do architecture, and there are a lot more ways than just architecture. For instance, you could do like a grilled cheese and you split it down the diagonal, and there you go, you get 2 congruent triangle grilled cheese sandwiches, something as simple as that. But I just want students to really be creative and always being on the lookout to see congruent triangles around them. Now, next they would take or draw a picture of these congruent triangles, then prove that the triangles are congruent, and lastly create a presentation that is about 5 to 7 minutes on the example and going through the proof. Now the rubric shows that it's only worth 20 points. I would probably bump it up with maybe a peer evaluation or something along those lines are just like multiplying everything by 2, but that's basically it. Now the assessment timeline, so the entry level is the KWL chart, which you'll find in my teacher lecture for lesson number 1. The formative is the quiz or the opener, whiteboards during class, 4 corners, which is one of the lessons, and also homework as well. Then the summative is the Congruent Triangles iPad project and the presentation. And lastly, right here is kind of like a 1-sentence summary about each of these assessments that you can find later. I'm going to go straight into lesson number 1, which is the teacher lecture. On the left and on the right, you can find the guided notes. So on the left, you can kind of see it, but because sometimes the structure of documents get kind of messed up with this script, I put the file on the right just in case for students to print it out that way. And the link to the lecture is right here. So I'm going to go to that. Right here we have my teacher lecture. So we have congruent triangles, what you know, what you want to know, and what you've learned. That's the KWL chart, and I've described it in these 2 different slides on how I want it to be done. So the third column, which is what they want or what they have learned, is done at the end of the unit. That's how I want it to go. So they need to have at least 10 items in total for the first 2 columns. And these are some of the examples that I provided, and I hope that they can come up with some on their own too. Next, I provide a review, which is just a really sweet, simple, different types of triangles and kind of a song. And it's really catchy. It's also super kiddie-ish, but it should help them remember the sum of interior angles, isosceles triangles, just different really basic things just to get them ready for this. And we have congruent triangles. What do you think congruent means? And what do you think it means for triangles to be congruent? Next is the definition. Then there's an example, a question, and now we're bringing in the 5 different ways to prove triangles are congruent. The first one is SSS. Then the next one is SAS. And I choose one of the 3 to kind of go through, or actually we do all 3, but one of them I specifically choose and we do a proof. And then the next one is ASA, and we kind of go through them too. Lastly, we do with a partner. That way they can really bounce ideas back and forth off of each other, and also we can use our whiteboards as well to basically choose which way we want to prove that these sets of triangles are congruent as well. And then we can kind of go into a preview into what we're going to learn tomorrow, which is finishing up the rest of how to prove triangles are congruent. So, like I said, there were 5 ways. We've proven 3 of them. Now we're going to prove 2 more. So that was lesson 1, the teacher lecture. The Weber size is now the iPad project. Now this is, I consider it kind of a project, quote-unquote project, but you can... it doesn't really have to be a project. It can be more of a homework assignment too. They're going to be using the iPad app Isosceles. The directions are they'll be constructing 2 triangles that are congruent by one of the 5 theorems. So first, they have to choose one of the 5 to prove that triangles are congruent. Then in their head or on a piece of paper, just like a scratch piece of paper, they need to make a list of properties and theorems that will prove that sides and angles are congruent, and this will really give them a lot of help into how to prove that 2 triangles are congruent out of the one way that they have chosen. Next, they have to put these together. They can use the Cartesian style of the app to accurately choose angles and lengths for their construction. They need to use the text button to include the steps in constructing the shape or the 2 triangles. And they have to use it again to give information and the proof. Include the given information and the proof, and then save the screenshot in the camera roll, or you can save the image to the camera roll, and then they would send this to me via email. Now, this is an example that I've created. It's just a rectangle, and with a diagonal down the center. I described how to construct it, and I did the given and the proof. So this is a proof using SSS. So they can use any of the 5. Next is lesson 3, which is a graphic organizer. It is basically a worksheet. So I have made 6 different columns with the 5 different ways to prove it, and also the not congruent column as well. And they have to include at least 5 sets of triangles in each of these. And at the end, then they have to prove from one of each of the 5 how they are congruent. So, for example, if we scroll down here, we have SSS, SAS, and ASA, and we have 5 of each. So 1, 2, 3, 4, 5. And each of them have 5. And then HL, AAS, and not congruent. Like I said, the structure kind of gets messed up, but they're right here. So HL, AAS, and then not congruent. And then we have the proofs. So the proof of SSS, the proof of SAS, and so on. So you can kind of find all of them down there. So that is a graphic organizer. Next, we have some unit resources. So first I provided a game and also some notes, good images, and being able to construct triangles that are congruent as well. So this one, though, they need to have Java installed, and I gave a little warning as well. And then these are some videos. Each one, some provide specific ones like ASA, AAS, and this one especially is just a little song, so that they can remember the different ways, because it gets really confusing with all of the different acronyms as well. So, for instance, this game right here, you can play it, and it's really cute. You just have to choose if it's true or false, for instance, like that. And we're not going to really go through it, but I just wanted to show you that these are some things that I could possibly ask on the exam as well. And lastly is just a digital unit plan. So it's given right here. You can kind of scroll through it. But it's basically everything that I've already stated, and you can find on my website. So yeah, if you have any questions, go ahead and leave that in the comments. I'd love to hear all of your reviews on this. But yeah, thanks for watching.